So I came across this video, and I'm blurring parts of it obviously, but in it a guy is just dragging his dog across the pavement. Now I love animals, so this is heartbreaking to see. I reported it to the RSPCA who handles cases like this. The problem is that the original poster isn't the one who filmed it, and you can't see the guy's face. So with no real info to go off of, this would probably go unsolved. But it doesn't have to. Because there's one thing in this video that 99% of cases like this don't have. This dog has a cone on it, meaning it probably had a recent vet appointment. So if we can locate where this video is taken, we can contact the nearby vets, see who recognizes this dog, and then they could send the info of the owner to the RSPCA. So let's locate this. Now right off the bat, we have these zigzag white lines, which are primarily found in the UK. Combine that with what we hear in the audio. I was pretty confident we were somewhere in the UK, most likely London. The first thing I did, it's 2026, so I just tried to reverse image search different things in the video. The results weren't great. Google really just wanted to sell me stuff. I also tried stitching together different frames and then generating an image based on that just to get a little more context. But again, nothing really came up. So I just went back to old-fashioned searching, trying a bunch of different things, one of them being this black electricity box. So just searching that, I found this Facebook post where someone said it's a pedestrian crossing and it's marked TfL Street Management. Now TfL is Transport for London, so that confirms we're in London. It doesn't help a lot determining where in London though. But I went to this location on Google Street View. In it, you can see this same style of like zigzag white lines and then these stoplights for the pedestrian crossing. And these electrical boxes are used to power and manage the stoplights for the crossing. So we know that this road is approaching a pedestrian crossing, but specifically a lighted pedestrian crossing managed by TfL. So I found this data set. It's the lighted or signalized pedestrian crossings managed by TfL. So let me load that into QGIS and we'll take a look. So here's London, and if I throw on that data set, you can see all of those crossings. It's about 6,000 in total. However, this data is for all traffic signals. So there's a field in here that is type pedestrian. If I filter to just that, it drops it from 6,000 to only 2,000. Now this part actually I think is a pretty important step to show. 2,000 pedestrian crossings for all of London seems really low. Like I'll just zoom into a random area here. You're telling me there's only 8 crossings in all of this? So I was a little bit skeptical that this dataset had all of the pedestrian crossings. So what I did was just check literally the first one I could think of, which was the one from this Facebook post. So we'll zoom out, grab the coordinate, paste it into QGIS here, and see the location. So this is it right here. The dataset is layered on, like you can see some down the street, but at this specific location, it's just not showing up. So that told me the dataset wasn't exhaustive. So I could have spent hours trying to filter down and apply different logic to that. And the whole time the crossing that I was looking for might not have been in there. So that saved me a lot of time from, going down a potential rabbit hole, but also I didn't have much else to go on. I looked into these fences. I found the exact model and manufacturer. The problem is these get installed all around London, so it doesn't narrow anything down. So really at this point, I was a bit stuck, and it's infuriating because, this is a picture that if you've been here, it's so easy to just recognize it, but trying to find it, there's just not a lot of identifiable info. So what we're going to do, this is an idea I've had for a while, but never could really justify the amount of work that it would take to set this up. Basically, I'm going to make a tool that you can describe a location with just text, and it finds the location that most closely matches that. And to do that, we just need two things. One is all the street view panoramas, and secondly is our description of what we're looking for. So we'll start with just getting these street view panos. Now we don't have to pull all of London, we actually know a few things about our location. First is that we're on a road, but specifically a T-junction here. This dataset from the UK government has all roads and it's exhaustive of, I think the whole island, but definitely London. So here's the dataset. It's absolutely massive. It's a couple gigabytes. If I zoom out anymore, it's just going to look like a pink blob. So I'll actually zoom in. I'll also switch this to satellite imagery so you can see. What I want to look for is just how exhaustive this dataset is. Any road from the satellite imagery is covered by this dataset. So that's beautiful. That's exactly what we need. The dataset also has these nodes between each link, and with a bit of code, I can identify just the ones that are on the T-junctions that we're looking for. So it removes all the dead ends and the four-way intersections. So the location that we're looking for is one of these blue dots, and in total, there are about 80,000 of them across all of London. So I can download the panos for those 80K. There's actually one more thing I can do to cut that down quite a bit. And that's because we actually have a little more info from these shots. So we know we're at a T-junction, but we also know it's a T-junction on a 2-lane road. Now this government dataset doesn't have the number of lanes. What does though is OpenStreetMap. Now OSM is just a site where people can tag different geospatial data on. For example, if I query what's here, there's a bunch of things. One is this Theobald's Road, and in it I can see lanes 4. So now back in QGIS, I just downloaded all of those OSM roads and I'll layer them on here, and then I'll just filter to only the 2-lane roads. So these blue dots are the 80,000 T-junction points that we're looking for. What we can do now is only keep the ones that are on these green lines. And that drops the 80,000 to about 20,000. Now there's one thing to note on this, and it's while OSM data is super rich, there can be a lot of different fields. It also relies on users uploading, so it's not present for everything. Meaning if we filter to just the 2-lane roads, we could be missing out on 2-lane roads if, no one ever tagged them as such. But you typically get better data in like larger cities and busier areas. So just based on this footage, it looks like a popular walking path. There's a bike going by in the footage. So I thought it was pretty feasible that OSM would have this tagged. And if not, I would know exactly what step to come back to expand the search later. Great, so we have the 20,000 points for all of London. Now time to download the Google Street View. The problem is Google's API costs $7 per 1,000 requests, so this would have costed me like $2,000 to pull. There is also an unofficial endpoint you could query. You just have to figure out the native panel resolution for each, figure out the tile size based on the zoom level, pull each of the individual tiles, and then stitch based on that. Not that I did any of that. But anyway, once you have your panos, it'll look something like this. Perfect, so we have our Google Street View panos downloaded. That's step 1. Before we go into prompting, I actually want to talk a little bit just about how any of this works. What all of this runs on is a tool called CLIP. Now, I'm not going to go into the science of CLIP. I'm sure there are much better videos with way more qualified people. What I'll show you instead is what it does and how we're going to use it. So I have a folder here with 4 images in it: a gray cat, an orange cat, a dog, and a waterfall. Now, what this program does is I'll input any prompt. For this example, I'll do cat. And what it outputs is each of our 4 photos with a measure of how basically cat-like it is. So I'll run it again, but this time with orange cat. And you can see that this one is more orange cat-like than this. But both of these are more similar than the dog, which is more similar than the waterfall. Now the actual units of these numbers don't really matter. What's more important is just the relative ranking between these. So the tool is pretty good at looking at an image and saying, oh yeah, that's pretty close to whatever you prompted. I'll show you now something that it's really bad at. So I've added these 2 new photos in the folder. Say we want a prompt to identify this one. So a gray cat to the right of a dog. So I'll put that in here and run this one. So this is our gray cat to the right of a dog, and it has basically the same score as the gray cat to the left of the dog. And both of these are pretty similar to just the gray cat on its own. So the model is very good at saying, hey, gray cat, yes, no. It's really bad at any logical or spatial relationships. The reason is it's trained on millions of image caption pairs. So the training data has seen thousands of images like this with a caption dog, and thousands like this with a caption similar to orange cat. But even if you had an image like this, when would you ever see a caption that says gray cat to the right of a dog? That's just not how people would caption an image. So we can't use spatial relationships in the prompt. Here's the way we get around that though. So say we're still looking for a gray cat to the left of a dog. We have our image, we split it, and we have it rate each side for its respective prompt. That's exactly what this code here does, so I'll just show you that output. So here it is, each side has its own prompt. The overall image is just the average of the 2 scores. And now with no change to the model, we are able to differentiate spatial relationships as well. So that's a little bit about how this black box works. I think now we're ready to start writing the prompts. We need to imagine what an observer around this area would see facing each direction. There are 2 main directions that we have info on. I'll call this way kind of the crossing view, and then this the side view. There's just not a ton identifiable looking down this street or looking towards whatever this is over here. But for the crossing view, we know quite a few things. So we're approaching that lighted pedestrian crossing this way. But if we zoom in right here, we can see this mark right here and right here. So what that indicates is the actual pedestrian crossing being right off screen here. So now for the crossing prompts, and this part is a bit of an art and a science, but the main things are traffic light, because since we know it's a lighted pedestrian crossing, we're going to see something like this. And then the second 2 are just more overall descriptions of kind of what you would see looking this way. And just a quick note on the black iron fences and more broadly kind of just what makes this more of an art. The prompt needs to be something that's 1, detectable, but 2, something that's unique enough to differentiate this. For the second one, knowing what's unique, you just kind of need a lot of context on what London looks like. I didn't have that. So I'll show you what I used because it's actually pretty cool. So in the video, we see a guy riding a bike. I thought maybe this was a bike path. So I found this data set. In it, if I go to cycling infrastructure, data, lines, and then this JSON, there's just a ton of data about each bike infrastructure thing. But each one has 2 photos. So then I pulled the JSON and just made a quick script that downloads all these images. And yes, I could have used Google Street View and walked down streets, but the time to load each one of those panoramas would make it take like 10 times longer to just look through the same amount of places. So with this, I was able to quickly flip through, a couple thousand of these and get a lot of context on London infrastructure. So what's common, what's rare, what's unique enough to make this scene identifiable from the other 20,000. So that's a bit of info behind this prompt and kind of a few of these other upcoming side prompts. On the side prompts, it's a pretty similar thing. Imagine yourself here looking this way. What do you see? Well, we're going to be looking down a road, a 1-lane road, yellow on both sides, black fence on both sides. We're going to have these yellow bump things, and you're going to see this box, but it's going to be behind a black fence. So I think that covers all the prompts I put in. Oh, large concrete pavers as well. So panos downloaded, prompts done. We talked a little bit about the technology driving the tool. Now, how is it actually implemented? Very similar to the cats and the dogs, but this time we have a Google panorama. We divide it into 8 different tiles, and each one has kind of an overlap so that if there's a feature that spans a border, at least one of them will capture it. So we start with the crossing prompt. We take this image and get its score for each of the 3 prompts, and then average it for the total crossing score for this tile. We do that for all the images and find the one that is most crossing-like. Not every panel will have a crossing in it, but every panel will have one that scores the highest. So we find that, and then we call that the direction basically facing the crossing. Now the Google Pano does actually say like which way the car was facing, and you might be tempted to use that here, but we don't know whether the car was approaching this or driving away from it. Or worst case scenario, the car was like turning onto this road and the crossing isn't forward or backwards. So again, just to be safe, I did it for all these and then found the way that it's facing the crossing. So then the next step is the side prompts, very similar. If you imagine yourself here looking towards the crossing, this side street would be to your left about 90 degrees. Or said another way, looking top down, it's counterclockwise 90 degrees. So that's why we figure out which way the crossing is, because then we look 90 degrees this way and we check this image. We actually also have to check these 2, and I'll show you why. So when we pulled the Google Street View image, we have these coordinates at the exact intersection that we want. When we query that Google endpoint, we actually include those coordinates, and then Google then returns the nearest panorama as well as its coordinates. Since the Street View car takes pictures every like 3 to 5 meters, these 2 coordinates might be slightly different. So all that's to say, we don't know if the image was taken here or here or here, but if it was taken here, we want to also look kind of roughly this way. So again, 90 degrees to the left, but we also check these 2. So same thing as crossing prompts, but we run it just on these 3 and we find the highest match. Then the total score for that panorama is just the average of these 2. And lastly, we do this 20,000 times. To actually do this, I'm using 2 models, B16 and 400M, we'll call it. Not important you know the names, but what you need to know is that B16 is very fast and not very smart. 400M is basically the opposite. It takes a lot of GPU power to run this on thousands and thousands of images. So the way I did this was I run all 20,000 through B16 and then take the top 10% of those. 90% are going to be woods or things without even a crossing in them at all. Then we take that, we run it through the smart model, and then lastly, the carbon-based life form, will look through manually and find the location. So that's it. All we do now is hit play and have my laptop sound like a jet engine for 3 hours. But at the end of all that, we'll have a ranked list of the best matches. So let's take a look. And so here they are. It has both the side and the crossing scores as well as the overall. I scaled up the overall too, just so it's not a super small decimal. But here's the number 1 result. So the red square is what it decided was the crossing, and then blue is to the left of that, the side street. So honestly, not terrible. I mean, it is a crossing. Black fences. Maybe it thought this was a stoplight, or maybe everything else just scored high enough to kind of carry that. But I mean, it is identifying the crossings, so I'll flip through these and just kind of check manually. This one here in number 8 is actually decent. I guess you would call these traffic lights, so points for that. But in 9th place is this location. And here's our crossing with the traffic light, black fences, and the white zigzag lines. I mean, the Google car blur is actually massive on this pano. On the side view, it's exactly what we prompted. It actually didn't even capture this electricity box, so I mean, it scored quite a bit lower because of that. But I guess everything else brought its average up enough to get 9th place. Okay, so I did this part after recording, but I want to add this. Now, 9th place out of 20,000 isn't awful. It narrows down your search to like the top 0.05% of candidates. There are some things I could have done better though. First off, while we don't know the cardinal directions from this footage, we do know for each given junction what the direction of the crossing should be. So for this pano, I would note to anchor it exactly at this angle. What that then allows me to do is, instead of relying on this prompt, which Clip is not great at, I can split this view exactly down the middle and take the left half, the right half, and then score each of those individually for the black fences. So I actually reran the entire analysis with these improvements. And so here was the 3rd place doing that. It looks a lot closer to what we'd expect. 2nd place, a little bit less so. I mean, there's not even a stoplight here, but you can see that reflected in its score. I mean, it scored basically median for stoplight, and it was really just carried by the left railing and the side street, which makes sense. I mean, take the left half of this, huge black railing in the center of the shot, and then the side street is exactly what we prompted. And then the number 1 pano now is actually the correct one. What's interesting is it didn't rank first on any of the sub prompts. It just consistently ranked really well across all of them. And ideally, it would have a bit more separation between 2nd place. But I mean, ranking first out of 20,000 in total is pretty decent. That was just something cool I wanted to call out. Back to the video. And so here it is in the actual pano, but we are not done yet. Because the whole reason for finding this location was not to find the location, it was to find vet offices around this area. So that's what I did, spent a couple hours calling and emailing basically every vet in like a 2-mile radius. And quick side note, I mean, this video is probably going to get demonetized just because the context of it. So if you like the channel and just want to help me keep doing stuff like this, consider joining as a member or liking the video. It helps a ton. Now, this is the part where I tell you one of the vets identified the dog and reported that info to the RSPCA. In reality, here's what happened. So this is the location of the video. Here are all the vet offices that I reached out to, along with a couple more niche ones a little further away. Most of them confirmed that the dog is not one of their patients. And so as the list was narrowing, there was still something that perplexed me about this whole case from basically the very start of it. Bulldogs are one of the most expensive breeds to own. I'm talking tens of thousands of dollars for the common issues and treatment that they need. So, I mean, you put your money where your heart is. Like, aside from just being an awful person to do this in general, why would someone do this to an animal they spend thousands of dollars on? Unless they don't. All of these are for-profit hospitals, except for one. PDSA provides care entirely for free, which is also probably why multiple vets I reached out to pointed me to them. And to be clear, none of this proves that the dog is a PDSA patient. I just think it's the most likely option by far. So the good news, PDSA requires that you're on need-based benefits and they verify it. They verify it with all the information you could want. Name, address, income, they have it. The bad news, they won't share it. And just because I know I'll get at least one comment on confidentiality, here's the Code of Professional Conduct from the RCVS. Chapter 14 on confidentiality. Section 2, information can be disclosed where disclosure can be justified by animal welfare concerns. There's basically an explicit carve-out for cases exactly like this. And just to be clear, I didn't ask them to send any client info to me, only to send it to the RSPCA, which again is explicitly carved out in that RCVS document. But they basically said if RSPCA doesn't ask for it, they won't send it. That's fine. I have an RSPCA case open. So I sent all that info, asked them to reach out, and they basically said, nah, we don't do that. So that's where I'm at right now. I wish I had a more satisfying ending. Reality is it's still evolving. I made a police report. I'm going to keep escalating with the RSPCA. Maybe someone there sees this video and will look into it. I'm going to keep pushing on this, so whatever happens, I'll be sure to share an update. That's it for now.